And welcome to the Daily Space Weather. As space weather kicks up, pardon my appearance, I look like a Muppet today. These are the past 24 hours from the SDO. And we've got a proton event going on, CMEs impacting, and all kinds of funky space weather stuff happening all at the same time. We're going to have geomagnetic storm conditions for days. If you haven't seen our previous Daily Space Weather content, maybe you ought to tune into it. Let's continue on with the Daily Space Weather. These are 24-hour videos of the closest star. And thanks for stargazing with us here at the Smash News Network, least busted name in news. Massive CME jumping off today from the southern hemisphere. If you don't see it well in this imagery, well, we'll show some different imagery. But that's the equatorial view for the past 24 hours. And there it goes. Here's the southern polar view, and watch this huge dark feature here right in the center of your screen. It's on its way out, and guess what? I failed to name that filament last night. So sadly, that one never got a name before it blasted off into space. So anyway, before we get to some more imagery here, this is the past. Dag, I really look like a Muppet today. Pardon my Muppet-like appearance. That is today from the SDO continuum. I will try to not appear on the thumbnail like a Muppet. So we've had an uptick in the radio flux and the sunspot number as we forecasted yesterday. There's a colorized magnetogram SDO HMI instrument for today to date is what that is. And let's take a look at some more imagery here. But first, we'll talk earthquakes and volcanoes. And before we get there, a quick adjustment to make. These are not 24-hour videos. These are less than 24-hour videos. I don't know. There was some kind of an error that was made. So we apologize. This is unrecoverable. So anyway, these are the volcanoes that are erupting. The list includes Subanose-jima, Mount Ibu, Merapi. Ooh, a massive eruption there at Merapi, including pyroclastic flows, which is not a good way to go. Semeru also erupting. Merapi, again on the list, occupying 2 spots on the list. Popocatépetl, San Chiguito, Sangay, Revenador, and Sabancaya. So a bunch of erupting volcanoes, and yeah, I don't know what happened today. It was some kind of a failure on my part. The fault was of this guy right here. This guy screwed up. And when it comes to earthquakes, we had one major quake over the past 24 hours, a 7 magnitude quake near the China-Kyrgyzstan border. And that one is expected to have done untold amounts of damage. Expect to see some shocking reports of that. How do I know? Because look at the pager, folks. The pager is red. It is a 7 magnitude quake, folks, that can be quite devastating indeed. So we'll get to that. We'll call out the quakes of a 5 and greater magnitude for the past 24 hours. Starting with this 5.0 at Indonesia. And then only about 30 minutes later, a foreshock at China. So a perfect example there of a 5.1 magnitude foreshock, suggesting the possibility of a larger quake. We talk about it all the time on the channel. Tonga also had a 5.3. That was at 14:20 Universal Time. And then, pow, kazam. A 7.0 strikes China at 18:09 Universal Time. And then a 5.8 strikes Kyrgyzstan. As the as the aftershocks continue. And you can expect those to go on for an extended period of time. From a quake that big, lots of 5 magnitude events to follow. Last but not least, Chile also had a 5.3 at 22:30 Universal Time. And let's get back to space. So here comes some more solar images. How about, that's whatever period of time. You can see the time and date stamps down there in the lower left. It is less hours than I would prefer to show, so let's speed things up a little bit today and break out the rest of the solar stats. The 10.7 centimeter radial flux now up to nearly 200. Radial flux now at 196 solar flux units. That's going to be updated again, 196, as the radial flux here once again flirting with 200. It's the black line depicted there on that 1-year graph. And space weather enthusiast dashboard here, like we said, expecting space weather for days. So both tonight and possibly into tomorrow night, but mainly throughout tonight and into late day tomorrow. One of the CMEs has already arrived, and it was fairly mild as expected. And we'll get to that here in a moment. And let's get to some more space weather stats. So here are the geospace magnetosphere movies for the past 4 hours. And the most recent coronal mass ejection impact has been fairly minor. So not really a big surprise there to our regular viewers, as this one, like the other two that are on the way, was forecasted. Here's Earth's magnetic moment from the ground. This will help you to discover where to see the aurora. Use the ground magnetic perturbations map. It depicts the last 4 hours of magnetic flux density, changes in magnetic flux density in Earth's B field, geospace delta B. KP index currently at 3.33. 3.33 is the KP index, an average of global geomagnetism, and next the real-time solar wind. So we did have a little stronger field kick up here when this CME arrived at ACE. The field went up to like 13 nanotesla. The plasma density made it up to just under 8 protons per cubic centimeter, and the solar wind velocity made it up just around 500 kilometers per second. It's already subsiding. It was a weak impact. Discover also showing an impact at the same time there. Similar magnetic field, 13 nanotesla. So a solid signal there. See, that's coronal mass ejection 1 of 3. The second one is going to be the strongest. The third one will also be a rather weak impact. So there you go. The Discover showing a little bit denser solar wind at about 10 protons per cubic centimeter. Solar wind velocity here creeping back down in between coronal mass ejection impact number 1 and number 2. Here are GOES magnetometers there, and a little bit of variations happening in those. No big deal. There are the past 7 days, and you can expect some wild variations in the GOES magnetometers moving forward. Next, our top view ecliptic plane field plot. As Earth remains in a South Pole heliospheric magnetic sector, that is what's depicted in red. And let's move on to our line of sight field plot. Here the solar B field is depicted in blue. That's the field that goes through the magnet, this magnet being the sun. The photosphere magnetism in grayscale, and the polar fields in green for red. Not green for red, green for north, and red for south. That's how things are. That's the magnetic field. Those are the magnetic fields depicted in this 4-day series of images from the National Solar Observatory. Next, coronal holes. Super important as they show us the solar polar field reversal process. That's what's going on with coronal holes. And let's move ahead to the SDO. So first, some 171 angstroms imagery. And let's skip ahead to coronal holes. There's the coronal hole situation, and it's pretty mild, but there is a continued uptick in coronal hole activity expected to continue here. So don't be surprised to see coronal holes continue to be frequently noted around the solar equator for the next year plus as we ramp up and up to solar maximum. That said, let's get back to sunspot number. Oh my God, what has happened? Dear God, what has happened? So, sunspot number, dude. Oh man, there we go. Sunspot number now back over 170. So the radial flux now at 196. Sunspot number now at about 172. Here is the synoptic map. We have a very high likelihood of large solar flares, mainly from Sunspot 3559. Let's get to our solar flare monitor and probability scoreboard. 3559 remains the T-mass, the most active sunspot. So there's our flare probability monitor and scoreboard. And just a quick reminder to never try to sneak up on a dragon in its own domain. You will not be successful in surprising said dragon, so just don't even attempt. So that's the sunspot situation, and let's just move on to solar flares. And don't worry, we've got some fresh images for your viewing pleasure. So, yeah, next, like I said, solar flares. And let's take a look at what's going on from the SDO's perspective. So first you've got the 94 angstroms wavelength. Those images are all from today, January 22nd, 2024. And indeed, the most active sunspot is actually this group down here in the southwest. So everybody's expecting it to be this group up here, but those recent M-class flares came from this group down here. So that's SDO 94 angstroms. We'll also show 131 angstroms. And we've made that a little bit slower for you there. Actually, it looks like we've got M-class flares in both of those sunspot groups. So that's raising the general likelihood of large solar flares, folks. Let's just briefly zoom out to show the full disk so that you are able to see the time and date stamps. There you go. That is January 22nd, 2024. As we get closer and closer to solar maximum, and I look more and more like a solar forecasting Muppet. Continuing right along, it's time to look at a star chart. But first, solar energetic particles. Yeah, we've got some now. And there you go, the goes proton flux. As you can see, seeing a little spike. A little bit of a proton event there. And it was associated with something before midnight, it looks like, or right around midnight. What do you got? Maybe this long duration C-class event? Not so sure, but some relativistic particles showing up and an uptick in sunspot number, radio flux, and the background X-ray flux, as well as the overall X-ray profile. Some M flares, like I said, we just showed them. Next, a star chart. So this is what's going on overhead Lehigh Valley, Pennsylvania. Ta-da! You got the moon, you got Jupiter, you got Saturn. All up there near the ecliptic. Next, our solar system forecast. This is where things are today. Let's advance this 1 week. As Earth moves around deeper and deeper into this gas giant free side of the solar system. Let's get to our astronomy photo of the day. But first, don't forget to ask a particle physicist a question. Yeah, you got a question for a particle physicist? Well, we've got a place to do so. My vest is all full of space. But particle physicists do stuff besides space. Ask Eugene the philosopher a particle physicist question, or just a physics question in general, if you like. You can do so at smashomash.com/forum. It's entirely free. We launched it back in 2019 to benefit people like you in advanced science. Next, the astronomy photo of the day, shadows of the mountain and moon. As the sun illuminates both this mountain and this satellite, creating a similar shadow on both and convincing some people that the Earth is flat for some reason. I don't know why, but that's the internet nowadays. Disinformation, fraud, and propaganda is promoted. So enjoy that. We won't be doing that. And let's take a look at coronal mass ejections. Coronal mass ejections. And there was indeed a massive one. One of the most massive ones of the entire solar cycle. That filament that we should have named last night, we didn't do so. and now it's launched. Right there, that was a very berserk CME, and don't be surprised to see that one having an earthly directed component. So here we'll show it from C2 and C3, and wait for it. There it goes. Absolutely spectacular. So that one likely to have an additional earthly directed component. Expect that one to arrive sometime on the 25th. So it's just going to keep continuing on with space weather, folks. It's an exciting time to be doing this. Let me bring that one back. That was a sweet freeze frame indeed. Look at that. Very, very dense material there making its way out of the corona. Just classic. If you need some natural fireball animations, that one looks like Dragon's Breath, wouldn't you say so? And let's show our custom coronagraphs here. Actually, let's skip those almost entirely because I didn't make them 24-hour videos today. So you'll see the initial blast there as that thing makes its way out. But unfortunately, this has been an error on my part. So, yeah. Anyway, moving along to filaments, because there are still some filaments. You're going to see this one erupting. It is pretty berserk. So check this out. Look at this filament in the south. It's there, and whoops, now it's gone. Part of it on the way to Earth. So that's a fourth coronal mass ejection to have an earthly directed component. As we're between the first one and the second one, striking the magnetosphere. So it's there, it's still there, and whoops, now it's gone. As it dissipates into the solar system, solar plasma. Should have named this one last night, but sometimes you just do too many things. Anyway, we're going to close out space weather with bonus features, starting out with the last couple of hours from the GOES 16 SUVI. So yeah, flare watch is now transferred to the lower right, the southwestern quadrant of the closest star. And we've got another active region rising down here in the southeast. Check it out. There it is. And let's get to bonus features. So satellite charging hazards are first, and we have some significant satellite surface charging hazards over India and the Mideast, and some in the Far East as well, but the main portion of it there in the northwestern Indian Ocean. Some significant surface charging hazards there could cause some communications breakdowns for satellites, so that's something to be aware of. GOES electron flux here, looking like it's cratered, as you would expect as some space weather arrives. So there it is in the 3-day form, and we can expect some very low anomalous readings of this in the coming 24 hours. So here's our electron shortage, the longest electron shortage of the year. That's the 1-year graph of the electron content, the electron flux, the relativistic electrons of greater than or equal to 2 mega electron volts. There's a forecast model from NOAA. I have no comment, and here is the ionosphere where it's measured. The F layer is what we're showing next. There it is, the F of F, the FOF2. And if you're saying, what the F does this mean? Don't worry, we'll show you the anomalygram. So there's the anomaly in megahertz from a 30-day median. Low frequency anomaly in red, high frequency anomaly in blue. If you're unfamiliar with the raw imagery, that should help clarify things for you. And if you're looking at this area right here, that is the South Atlantic anomaly, the weakest portion of Earth's magnetosphere, followed by the South African anomaly. There's also one over here near Korea, and I'm not going to dwell on it because guess what? It's not that big of a deal. But that's what's going on at the bridge between Earth and space. Here is the global ionosphere nowcast, the WAM, known as the whole atmosphere model. And that's going to depict total electron content and anomaly on the left, maximum usable high-frequency radio frequency on the right. So that's your HF radio and GPS information. We'll close out space weather with the largest images we can get. So here's the new flare player. And here's 3359, which is nothing to sneeze at anyway. Now, why you would sneeze at a sunspot, I don't know, but it is known that if you look at the sun, you may discover that you have triggered a sneeze. And hopefully we haven't triggered you to get angry about sunspots, because, it's very delicate on YouTube nowadays. You don't want to make anybody mad about sunspots. So there are the over 170 sunspots currently visible on the Earth-facing portion of the disk, as at least one new group tries to rise over the southeastern limb. That said, it's time to move to meteorology, and let's talk about the world's stormiest seas. Yeah, there you go. There are the highest waves in the world. They're like about 12 meters or nearly 40 footers there in the North Atlantic. That is the stormiest portion of the planet there, right there for all you seafarers, although this area down here is an honorable mention. Not quite as violent as the activity in the North Atlantic. So those are the stormiest seas, folks. And let's get to our regularly scheduled meteorology segment. Surface winds of the east depicted here. Jet streams of the east depicted there. Jet streams of the central world here. Surface winds here. These are the surface winds of the Americas. And like sands through the hourglass of time, these are the jet streams of our lives. Next, clouds and fog over the Americas. It's our shortwave radiation map, and we'll also show the visible satellite for all of you left coasters. There's the left coast. The land of fruits and nuts, otherwise known as California. Which is not to say anything derogatory about citizens of California. The government of California, that exists. That's a visible satellite for the East Pacific. As more moisture is headed your way, California. So here is our precipitation type map, and let's actually switch to... Let's do a snow depth check. We haven't done that for a while. There's our snow depth. And quite a bit of snow cover there over the U.S., including Lehigh Valley, PA. Let's take a look at our weather.gov map. That's the forecast in terms of weather warnings, and we've got some significant flooding, like we mentioned yesterday and 2 days ago, in places like Texas. Yeah, Texas. Anyway, if your location's lit, click your location at weather.gov. Here comes some forecasts, starting with the GFS 72-hour pressure and precipitation model. So yeah, ice storm on the way. It has been partially canceled there. However, there will still be some freezing rain. So take heed of that pink on the map. That is suboptimal driving conditions, to say the least. Pressure and precipitation, GFS 72-hour model. Next, accumulated positive snow depth change in inches, GFS 72-hour model. I'm hungry, GFS 72-hour model for rain accumulation. And look at that, dude. How about over a foot of rain in portions of Mississippi, Louisiana, Texas? Dude, how about a foot of rain in some of those areas? That is serious. Pacific Northwest also going to get plastered, but not like those areas. That is some serious moisture. Bring your kayak and your hard hat. Next, temperature anomaly forecast in degrees Celsius. Some warm temperatures coming to the east to melt a lot of that snow. Warm temperatures coming to most of the country there. for the next 72 hours. 72-hour GFS temperature anomaly forecast in degrees Celsius. Lots of 12 and 14 degree above normal temperatures, especially east of the Mississippi. Next, clouds and fog. Not clouds and fog. That's lightning. That's what it is. Lightning. And here's a real-time lightning map from lightningmaps.org. Next time you hear thunder, I highly recommend it. You could convince the natives that you're Thor, or perhaps convince somebody that you're a horror movie villain by forecasting thunder, by saying something cringy just before thunder rolls in. You can do it. Forecast thunderclaps with lightningmaps.org. We'll close out with U.S. Doppler radar. Not for the full 50 state, although there it is. It'll be for the lower 48. There that is. Clouds and fog. There that is. Water vapor. There that is. And here is the recap. Vertical motion of the air column. Clouds and fog. And the water vapor, which should clear up your Doppler if you are unable to forecast the weather. The water vapor map should play a role in that. And hopefully you're able to forecast your own weather. Hopefully we've helped. We'll see you soon. In the meantime, I've been your host, Dan, a.k.a. Smash-O-Mash. Again, my vest is full of stars. And may that solar wind be at your back. Whoa.